Okay, all right, so let's go ahead and get started. Welcome everybody. Thank you for attending this webinar about Introduction to Helm. This is going to be mostly about creating your own Helm charts, more so than actually using Helm. So this is a bit of an maybe an advanced topic. If you have not used Helm before, I recommend you're probably going to want to go and just try it out. It's pretty simple to get started with, and then you can always replay this video and get some tips on how best to create your own charts to share with your own team or even to share outside of your organization. But this is mainly about how to create Helm charts and integrate them into your deployment process, your deployment pipeline, and how that can streamline how you deliver your applications. So with that, let's go ahead and get started. So a little bit about me. I'm Nick Ramirez. I write content for HAProxy Technologies. So you'll see my writing in our HAProxy blog. We created a couple of videos on YouTube that are pretty good. You should check out. There's some really good beginner tutorials about several different topics, including logging, statistics. So I definitely say check that out. And of course, our documentation, which we're always trying to make better. If you have any suggestions about any of our content, hit me up I'm on Twitter, or you can always just tweet to us directly at HAProxy Technologies, and we love to get your feedback, and we're always trying to become better. I live in Ohio, in USA. I'm a chess player, not a good chess player, but decent. I'm trying to get better. That's my new hobby. I probably start a new hobby maybe once every 6 months. Hot sauce, I'd say if it came down to it, I'm more for the mild hot sauce. I know that's probably going to be controversial, but I like flavor more than hotness. DevOps, if you guys have not read the Phoenix Project, I recommend reading that as soon as this ends. Just go and get the Phoenix Project. It is such a tremendous book that details the reasoning behind DevOps, and a lot of this stuff like Helm came out of this thinking and this new paradigm of how we approach deployments, how developers and operations people can work together to streamline how we deliver software. And some of the tools that came out of that, like Helm and like Kubernetes, I mean, you really have to have the sort of overview, the people perspective before you really dive into this stuff. But once you get into that, the tools really help. So Helm is going to be a big part of that. So in this, what we will cover, it's going to be an intro to Helm. So if you're not familiar with Helm, it's going to be a little bit of that, but it's going to be mostly about how to actually create your own Helm charts. We are going to show a simple example of making a Helm chart, and then we're going to show how to set up a repository where you can store that chart for other people to access it. And maybe that's people outside of your organization, but it may just be people inside your organization. This could be a helpful tool just for delivering software as part of your continuous integration, continuous delivery pipeline. And then I'm also going to cover when is it useful to add an ingress to your chart. HAProxy, we of course have our own Kubernetes Ingress Controller, and I'm going to show you when it's useful to add an ingress into your Helm chart so that when you deploy your application, it automatically wires itself up to have a route that people can use to access your application. So first off, why Helm? So what are we trying to do here? What is the problem that Helm solves? And it's the packaging problem. So when we think about what's already out there, you've got kubectl, or kubectl, as some people like to call it. And kubectl is really great because it's built into Kubernetes. Well, it is a separate download, but it's basically the CLI tool. It's the tool that you would use to interact with your Kubernetes cluster. So you would use Kubernetes kubectl get pods to see all of the pods that are running, or you would use kubectl apply to create new resources based off of the YAML files that you've written. The nice thing about this approach is that it's declarative. So YAML files, they are not procedural. They're not a programming language where you would say, if this is true, then I will do this, or else if this is not true, then I do this other thing. It's really setting up sort of an intent. You're saying, I want the system to look like this, and then you say kubectl apply, and it makes it happen. You don't really have to know how it works or what the inner mechanics of it are. You just say, this is what I want the system to look like, and it sort of happens. So that's a good part of it. The bad part of it is when you start to build a lot of these YAML files, it can sort of grow out of control. You can start to get lots and lots of these files because you're gonna have config maps, secrets. If you're using persistent storage, you're gonna have persistent volume claims and all these different sort of resources that are going to start to seem a little bit unmanageable. And so that's something that Helm tries to address. When it comes to sharing components, of course you can always put your YAML files into Git. You can put it in the source control, and then that's how you would share it with a coworker. But what happens when you need to make a change to one of those files or multiple files? How is it going to affect that person? So YAML, storing it in Git, it doesn't really have a built-in way to say this is a new release. This is a new version of my files that I'm now sharing. Whereas when you have a true packaging system, that's kind of what you get. You get a way to say this is release 1 and this is release 2, and the person who's using that really doesn't need to see the internals of that. They can just kind of see the external package part of it. So kubectl doesn't really have that. And then when you're using YAML files, you get limited lifecycle management. So that means when you want to upgrade, when you want to do a rollback, how do you do that? I mean, that's more or less having to go into a YAML file, change something, which may mean changing like the tag on a Docker image, and then reapplying it. But that's not really a mature lifecycle management. Whereas once you get packaging, that's where that sort of thing really comes into play, where you can say, okay, now I have a built-in way to say this is version 1 and I'm upgrading to version 2, or I'm on version 2 and I'm going to roll back to version 1. So Helm is the Kubernetes package manager. It's just about as close as you can get to a standard as there is. There really aren't a lot of alternatives at this point to Helm. So if you want a package manager, this is pretty much the way that you have to go. And it comes with 2 major parts. The first part is kind of the specification. How do you define a chart? Helm lays out the format for a package, which is called a chart. And the other part of it is the tool that you use to install those packages, or to query packages, or anything that involves a package, creating a package or installing it, is built into a tool, which is also called Helm. So that on the command line, you'll see it called Helm. So Helm kind of brings the bliss of packaging. It gives you the ability to do repeatable deployments. So that's something that we're all looking for, right? We're looking for a way to create a safe, repeatable deployment process where I can deploy the same application at the same version 100 times, and it's going to work every time. And you're taking the human element out of it. You're putting in automation. The other part is you can share components across projects. So a Helm package, a Helm chart, you can embed that into other Helm charts, and you can create sort of these umbrella charts that have smaller components built into them, and they sort of build up to something really complex. So Helm can be really powerful in that way. You can store packages in repositories. Whereas if you're not using packages, you're probably going to have to use a version control to download the source code or come up with your own method of doing it. But once you actually have a packaging format, you can hand that off to somebody else and you can store it in a repository. Helm comes with templates, whereas with YAML, there really isn't a way to add variables or if statements or anything that would change the YAML at runtime. But once you start using Helm, you can create templates that do have those things, and they let you modify the behavior of the package at runtime. And that's kind of the next thing I'm talking about. At runtime, a user can change the default attributes that you set on your package so that they can tune the package so that it's right for them, and you can expose the different toggles and settings that you want to make available. And then of course, well, just like we said on the last slide, Helm brings lifecycle management. So now you're going to be able to upgrade packages, roll back packages, and really have better control over the entire process. So there are some downsides. I don't want to make it seem like Helm is completely perfect. So the inner workings of Helm are kind of hidden. You're just seeing the package, the external part of it. Whereas you may say, well, now I don't really know what the YAML looks like. So that could be a good thing. Maybe it's good to hide some of that complexity and to only show this package. That could be a really good thing. But it could also be a bad thing if you say, well, it's a little bit opaque now. I don't understand exactly how this package works, especially if it's a package that somebody else built. So that can be a challenge. Templates, although they are extremely powerful, you can add variables and if statements. They can be a little bit hard to read once they start adding a lot of those sort of things. So that's something to be careful about, but it doesn't have to be that way. You can always sort of choose how much complexity you want to put into it, and try to contain that, and maybe not expose quite as much runtime functionality, but it's a fine line. So that is one of the challenges. It adds complexity to your build process. So you're probably already familiar with a build process that already has quite a few components. You probably have to check your source control out, or your code out of Git. And then if you're building a Docker image, you have to potentially host your own Docker registry if this is an image that shouldn't be public. You would now have to add a new Helm repository and build the Helm package as part of your build process. But as we're going to see later on in this presentation, it's really not as bad as you think. Setting that up and creating a Helm package really isn't that bad. And let's be honest, there are all sorts of things that we're already having to put into our build process, whether it's linting tools, security scans, unit tests, maybe you're doing canary deployments at the end of your build. There are just all sorts of things, and this is once you have it automated, you probably are not going to have to go back and tune it too much. The other thing is Helm at this point doesn't have a built-in way to just flip a switch and say this package is now running in a dev environment or a QA environment or a prod environment. There are ways to accomplish that, but it's not quite built in. But then again, this is a packaging product, right? Or it's meant to create packages, and creating support for these different environments. Maybe that's outside the scope of the Helm project, but we'll see. It's a project that continues to grow, and maybe that's something they'll add later. Installing Helm is really easy. It used to be in prior versions that you had to install a server-side component called Tiller, which would be installed into your Kubernetes cluster, and that was sort of the component that would listen for Helm commands and make it happen inside the cluster. You no longer need to do that. So now you can simply install Helm, which is a single binary written in Golang, and you just point it at your Kubernetes cluster, and you start using it right away. So it's become really easy to use, or at least really easy to get started with. So in this next section, I want to show you how to create a chart. It's going to be a simple example, and I hope it's going to give you a good overview of what's involved. When you create a chart, you can use the Helm create command, and it will bootstrap the entire Helm directory structure for you. So that's really helpful because it means you don't have to memorize exactly what the directory structure should look like. This is going to create all of the files. It's going to add several sample files to your directory, and you can either build off of that, or you can just go and delete those files and create your own. But this is a good way to get familiar with Helm and make sure you're going down the right path. So we're going to talk about several of these files that are in this directory in the next couple of slides. So the first one I want to look at is chart.yaml. That is the manifest for your chart. So this will describe the name of the chart, the description, and also the different versions that of your application and the version of the chart itself. So at the top you have the API version. It should be v2 for charts that require at least Helm version 3. Not sure why it doesn't say v3 there, but probably just has to do with it used to be version 1 when it used Tiller, and now it doesn't use Tiller, and now it's version 2. But yeah, that may be kind of interesting. The versions at the bottom. So the version is the version of the chart itself, and then the app version would be the version of the application that's contained within the chart. So if you're deploying a web application, which may have several components, it may have config maps and deployments and a service and several different things, but it all kind of boils down to one application. So you can put the application version there, and it does not have to be in sync with the version of the chart. So if you want to make changes to the chart itself, which don't affect the application, those two numbers can change independently. The next file is values.yaml, and this is where you will store any variables that you want to use within your chart. It's basically a map where it has key and value. In this example, I've set a couple of different variables that I want to use within my chart. One of them is going to be how many replicas do I want to create? The other is what port do I want it to listen on? And then what's the image of my application? What's the Docker image? You can create a nested hierarchy of these variables, but the official Helm documentation recommends that if possible, you try to keep this as flat as possible. And that's just going to make it easier to use. It's going to make it easier to reference these variables later on. So this is just as a really simple example. We've got 3 variables here, and you'll see how those come into play in the rest of the chart. So the next file is under the templates folder. And this one is going to be our deployment. This is going to be our deployment resource, our Kubernetes deployment. And you can see right away that I'm using several of those variables that we defined in the values.yaml file. Right at the top, you can see for the replicas, I reference the variable by saying .values. And then the name of the variable. So here's .values.replicas. You can create as many custom variables as you want and reference them just like this. You can also use several of the predefined variables, such as where I'm using .release.name. I didn't define that. That's something that just comes with Helm, but it gives me the name of my chart. And that's really useful because that's something that I use in multiple places. So as you look at this, just kind of look to see, these are the same variables for the most part that I defined in my values.yaml file. So there's plenty more that you can create with Helm. I didn't go into a lot of it. That is just a basic example of creating some variables and creating a few templates. You can get into creating subcharts and all sorts of things like that. But let's see how to create, how you would actually install this. Helm install is the command that you would use to actually install the chart. And you don't have to package it first. You can, when you're building it, you can just point to the directory where all your files are. Helm install, when you give it the dry run flag, means that it won't actually install it on your system or into your Kubernetes cluster, but it will just show you what would have happened if you had done that. So when you do this, some of the output that's displayed are the date that you're deploying it, the status, which when it first starts is in the pending mode. It's going to show you a revision, which isn't exactly useful now, but once you have deployed once you've deployed one version of your Helm chart and it's running in your cluster, and then you upgrade it to a new version, this revision is where you're going to be able to see different releases and be able to go back and forth. It's going to show you the user supply versus the computed values of your variables. User supply would be like the user changed one of your default variables when they ran your chart. And we'll see an example of that on the next slide. And it's going to show you a preview of all your templated YAML files with all the variables filled in. So this is really useful if you're building a chart to use the dry run flag to see exactly what you're going to get. So here's an example of installing it, but changing one of the variables when you use the chart. So you would use the set flag to change one of the variables. So in this example, I am changing my replicas variable to 5. And I can, if I don't set this, it's going to use what was set in the values.yaml file. But this gives your user the ability to have control over how they want to use your chart. So, and you can expose as many of these as you would like. It's basically any of the values that are in the values.yaml file. Once you get a lot of those values, once you begin to find yourself using a lot of these set flags, it's a little easier just to store all of them in a file. And you can basically just have a YAML file in the same format as your values.yaml file, but the new file will override those values. And you would just feed that into the Helm install command using the -f flag. So that's just going to say, here's a file that are my overrides. And it makes it a little bit cleaner if you have a lot of values that you want to use. So now I want to show how to publish your chart to a repository so you can begin sharing it with the world or just with your team. So a repository basically contains two things. It has an index.yaml file, which is it's the index. It shows you all of the packages that a person could get from your repository. And the other thing it has are all of your charts. Charts, when they are sent to a repository, are zipped up as .tgz files. And they're basically just zip files. You can, if you were to unzip them, you just see your directory again. The interesting thing is you don't have to store your charts in this repository. As you'll see in this presentation, I'm storing mine on GitHub, and as GitHub releases. And so I'm not storing the package charts themselves. I'm only storing the index.yaml file. And the steps to add something to a repository are basically you're going to package a chart, you're going to add that new chart to your index, and then you're going to push the index and possibly the chart to your repository. Here is what an index.yaml file looks like. This is with just one package in it. So as you can see, it's basically a list. And you can see that where it says my chart, that's the list of all the different versions of my chart that are available. And in this case, you can see 0.1.0. That's the version that you can download. It's the latest version. But once you start adding more, you're going to see more of these items in the list. And it's going to describe all the same sorts of things that you would get in out of your charts.yaml file, out of that manifest that's in the chart, along with a couple of other things like a digest of the package and a URL where you can actually download it. So as you can see here, under URLs, it lists a URL that's under GitHub. This is under the my GitHub releases page. So this isn't pointing to a local directory in the repository. It's pointing somewhere else. So it's perfectly valid to do that, to store your charts somewhere else, and then just reference the URL where the user can find them. So this could get a little bit complicated. I'm going to walk you through it. This is perhaps more complicated than you would do it. There are several ways to do this. For example, there is a software called Chart Museum that will host a Helm repository for you, and makes it pretty easy to add charts, and it comes with its own CLI to be able to add charts. But if you want to share your charts with the world, what I have found, and this is the way that we do it at HAProxy, is store it on GitHub. And it's just something that's kind of available for you to use, so why not? So the process that I will show here is not exactly how we do it. For HAProxy, ours relies a little bit more on some shell scripts and is a little bit more complicated because it is integrated into our CI/CD pipeline. So there's more integration, more things are kicked off based off of triggers that happen within the CI pipeline. This is basically the bare bones of what it really is doing, just maybe in a slightly different way. So the first thing you would do is you would check out your master branch from Git, and this is going to contain all of your Helm files, so all of the files that we were just looking at. And you would say, okay, I'm ready to release this as a chart. So you're going to use git tag to say this is a new version, and then you're going to push that tag to GitHub. And ordinarily, when you push a tag to GitHub, it creates a release for you. Unfortunately, it only creates download links for your source code. So you need something else that is going to attach the actual zipped up package to your release. So the next command, Helm package, is what actually creates that zip file. You would point Helm package at your directory, and it just creates it, and it's pretty simple. A tool that I found useful is called GitHub Release, and it has it makes it really easy to create a release and then attach a package to it. So GitHub Release, the first command, I'm basically creating a new release, but I'm referencing that tag that I already uploaded. I'm saying this is my repository, this is the name that I want it to have, and maybe a description. And so it's going to go out and create that release. If it's already there, I believe it overwrites it. So it's going to kind of take control of that. And then the next command, you're going to upload your package. So GitHub Release upload, you will point it at your repository, say which tag you're targeting, and the file that you want to upload, so the local file, and then what you want that to be called. And it's important when you name it that it does have the file extension that it should have. That way, when somebody does download it, it's going to come down as that type of file. So at this point, you have created a new release in GitHub, and it includes your zipped up chart. And it'll look like this. So here's my release. You can see that at the very top of the assets, I've got my chart as a .tgz file, and that's basically what the commands before did. The next thing you want to do is you want to upload the chart to GitHub Pages so that it's available for other people to actually download and use. GitHub Pages is something that GitHub offers for free. It creates a web page based off of a repository. So the way that I've seen several projects do it, including the HAProxy Technologies project, is to use a separate Git branch to store your index. So while the master branch contains your actual source code, your Helm files, this other branch just has an index.yaml file in it. And that way you're sort of keeping the source code separate from the repository. So I check out the new branch, GitHub Pages, and then I want to create the index file that I'm going to upload to that. Helm repo index is what creates the index file. Helm repo index looks at the directory where you've stored the .tgz file. So if you have a directory with lots of these files, or maybe just one, when you run this command, it is going to create the index.yaml file based off of that. If you already have an index.yaml file, you would use the -merge flag, and that's going to make sure that it doesn't wipe out, it's already there, and it just adds the new packages to the existing file. So once I run Helm repo index, it's going to create an index.yaml file locally. I'm going to add that to Git, and then I'm going to add a new commit, and I'm going to push that to my branch. So now at this point, I have index.yaml file in its own branch up on GitHub. And now at this point, if you've enabled GitHub Pages, which is basically just a checkbox, you just say, yes, I want to use GitHub Pages, and it kind of sets it up. A person is going to be able to go to a URL that looks like this, name your company.github.io / the name of your repository. So it's going to basically do this for you once you've uploaded the index file to your repository and you've said, I want GitHub Pages to be watching this repository. It's basically ready to go. So users can add that repository to their list of Helm repos using the Helm repo add command. And then they can install your chart. So then they say Helm install, give it a name, and then say, here's the name of the chart that I want. And then they basically have it. It's running in their Kubernetes cluster. They can use kubectl, get pods, and they'll see whatever application you're running there. And it's basically as easy as that. So once you've got this installed, you can see that all the complexity of the YAML files is hidden away. The end user just is interacting with these very simple commands. So next I want to show just kind of an added bonus of why you would add an ingress to your chart. So we already saw the directory structure for a chart. So now we're just adding one more file. This is ingress.yaml. And inside that file, you're going to create an ingress resource. An ingress resource creates a way for a client who is outside of your Kubernetes cluster to be routed to a service that's running inside your cluster. So ordinarily, services are sort of locked away inside the cluster that can only be accessed by other things that are running inside the cluster. They only get a cluster IP. So when you create an ingress, you're declaring that you would like people to be able to access your application such at a certain path, URL path, or maybe if they use a certain domain name, you would like that to be routed to the service. And here I'm using some of the built-in variables and some of the custom variables. So release.name, that's still there. I want to call this, my chart-ingress, and we're still using the port that we'd used before. This is basically just going to say, okay, we've already got a service defined in our chart. It's already running out there at a certain port, so we just need to specify that again so that ingress knows how to connect to it. And then I've added a new variable called host that a user can, when they're installing the chart, can say, I would like for this to be exposed at foo.bar. So that way, when somebody goes and actually deploys this chart, it just kind of gets wired up and they can immediately start accessing the application at that domain name. So the process for doing this is to basically do what we did before. We're going to create a new release in GitHub. We're going to upload the new zipped chart file, update our index, and then deploy the chart using Helm upgrade in this case. So Helm upgrade is going to remove the old version that we had before and install the new one with the ingress. And when you use Helm upgrade, it's going to be incrementing that release version. So if you needed to, you could always roll back. So getting into a little bit about what does an ingress controller do? Why would you want to use an ingress? So an ingress is a rule that defines a route from the outside of your cluster into to a service running inside. An ingress controller is a thing that satisfies that ingress. So without a controller, an ingress doesn't do anything. It's basically just a declaration. It says this is what I want the system to be. But you have to install an ingress controller to actually watch your cluster and put it into action, right? So at its core, an ingress controller is just a proxy. So the HAProxy Kubernetes Ingress Controller is running HAProxy at its core, and it is running in a pod inside your cluster. and it is watching your cluster for any new ingresses to be defined. So as soon as that ingress hits the cluster, the controller sees it and adds a new route within the proxy. And HAProxy has the ability to do this based off of a URL path or a domain host name. So either way, you can expose your application either way. I actually think I have a chart slide about that in just a couple minutes. To deploy the HAProxy Ingress Controller, we're already using Helm, so you can just use Helm repo at HAProxy Technologies, and then the URL of our Helm repository, which is on GitHub, and then just install our chart. So HAProxy Tech / Kubernetes Ingress. If you wanted to, you can also customize it with values like load balancer. If you want to run this as a load balancer, you just set this flag. Otherwise, it's going to run with a node port in front of it, which is pretty convenient for testing. You could set it up. It sets it up on a random port, and you just need to query for what that random port is, and then you'll be able to access any of your applications on that. So it basically looks like this. If you're using a load balancer, it's going to be from the client to the load balancer, and then it's going to route traffic into the ingress controller, and then it is going to do the layer 7 routing to say, based off of the URL path or the host name, which service is this person trying to reach? And then it's going to direct you to the right place. So the external load balancer really doesn't need to do much. It can be basically just a simple layer 4 load balancer, but the ingress controller is doing all of the kind of smart layer 7 stuff. And once you start using ingresses, like I said, you can base it off of the domain name or a URL path, and this is kind of what it would look like, where it's like foo.bar or bar.foo, either of those, once you've included this ingress in your package and somebody has installed it, it'll just kind of get wired up like that. Of course, you would have to set up DNS, but that's kind of outside the scope. But the proxy itself, the ingress controller, is ready to receive those requests and knows where to put them. And the other way to do it would be to say, I just want to use one domain name, maybe it's foo.bar, and any URL path like /shop or /API is going to be split off and go to the right service depending on whatever that string is. So that's the other way that you could do it, depending on how you set up your ingress. So that's basically it. Hopefully this has given you a very quick overview of Helm, and it's a really powerful packaging tool. And of course, we use it at HAProxy to package up our HAProxy Kubernetes Ingress Controller, and it's really made it simple for people to get started, and that's one of the things I love about it. So this time, if you have any questions about what I went over, feel free to put them into the questions panel in the GoToWebinar window, and I will see if I can answer them. And while we're waiting for that, here are a couple of other resources to get started, or to get more information, I should say. So you can go to our website. You can, there's our support number if you're already an HAProxy Enterprise user. Our knowledge base has several good articles related to microservices and just getting started in general with HAProxy. Of course, we're on Slack, so join us on Slack. There are always people there talking about stuff like this and answering questions. So it's a really good place to get started. Okay, so we do have one question. And sorry, Sanad, if you're talking, I can't hear you. So I'm just going to kind of read over the questions and try to answer them myself. I apologize. So one of the questions is, does the ingress controller live inside the AKS cluster? So there really isn't anywhere that you cannot use the ingress controller. I mean, if you've got a Kubernetes cluster, whether that's hosted or it's on premises, it really doesn't matter. It's because it is just a pod that's running inside your cluster. And the thing that makes it special is that it is hooked into the Kubernetes API. And so it's able to watch the entire cluster for changes, but itself, it's really something that's just a pod itself. So no matter where you're running this, whether it's in the cloud or on premises, you can use this. And it's actually, once you're running it, if you are happen to run it in the cloud, then you can use load balancer to expose it through the whatever cloud provider's load balancer technology is set up. Another question, what is the difference between Helm charts and OpenShift templates? So my understanding is that OpenShift templates predate Helm. So Helm wasn't around when they created that, and so they sort of had to roll their own solution to the entire packaging delivery problem and templating problem. And I would think perhaps if they were to do it again, they may just use Helm, but that's kind of where the two kind of came from, that OpenShift sort of created their own way because Helm wasn't